Wireless networks. First of all, Bluetooth and Wi-Fi. Both Wi-Fi and Bluetooth offer wireless communications between the devices. They both use electromagnetic radiations as the carrier of the data transmission. Bluetooth sends and receives radio waves in a band of 79 different frequencies, which are known as channels. These are all centered on 2.45 gigahertz frequency. Devices using Bluetooth automatically detect and connect to each other, but they do not interfere with other devices since each communicating pair uses a different channel from the 79 options. When a device wants to communicate, it picks one of the 79 channels at random. If the channel is already being used, it randomly picks another channel. This is known as spread spectrum frequency hopping. Spread spectrum frequency hopping. To further minimize the risk of interference with other devices, the communication pairs constantly change the frequencies or channels. They are using several times a second. Bluetooth creates a secure wireless personal area network, WPAN, wireless personal area network based on key encryption. Bluetooth is useful when transferring data between two or more devices which are less than 30 meters apart. The speed of data transmission is not critical using low bandwidth applications, for example, sending a music file from a mobile phone to a headset. As mentioned earlier in this lecture, Wi-Fi also uses spread spectrum technology. However, Wi-Fi is best suited to operating full-scale networks since it offers much faster data transfer rates, better range, and better security than Bluetooth, obviously. A Wi-Fi enabled device such as a computer or smartphone can access, for example, the internet wirelessly at any wireless access point, WAP, or hotspot up to 100 meters away. As mentioned earlier in this lecture, wireless connectivity uses electromagnetic radiations, which are radio waves, microwaves, or infrared. The scale of uh, frequency and wavelength of magnetic radiation is shown in this table. Observe this table. From radio waves to gamma rays, frequency goes down, and from gamma rays to radio waves, wavelength goes up. So you need to just to observe this. You don't have to remember this for exam. This is just the frequency and wavelength of the magnetic radiation. Now, the comparison of these electromagnetic radiations, radio waves, microwaves, and infrared. Uh, so for the bandwidth is the amount of data which is flowing through the network in 1 unit of time. In from infrared, microwave is better, and from microwave, radio waves is better. Uh, Greater than symbol in this illustration uh, means better than. For the penetration, radio waves are greater than microwaves, and microwaves are greater than infrared, means that radio waves have the best penetration. Attenuation. Penetration means that whatever the obstacles that comes across, these magnetic radiations can move through them. For example, walls, furniture, trees, mountains, etc. And then we have got attenuation. Attenuation is the weakness of the signal as a result of distance the signal travels. So in attenuation, radio waves are better than microwaves, and microwaves are better than infrared. Means radio waves have the best attenuation. Penetration measures the ability of electromagnetic radiations to pass through different media. Attenuation is the reduction in amplitude of signals. Infrared has low attenuation because it can be affected by, for example, rain or even internal walls. Thus, we would expect infrared to be suitable for indoor use only. The fact that it can be stopped by walls is seen as an advantage since this stops the signal causing interference elsewhere. Microwaves, on the other hand, seem to offer the best compromise since they support reasonable bandwidth and have reasonable penetration and attenuation. Now, uses of satellite as they are part of wireless communication as well. The use of microwaves and radio waves was mentioned in this lecture early as a method for allowing Wi-Fi connectivity in networks. These methods are perfectly satisfactory for short distances. The electromagnetic waves carry the signals, but the curvature of the earth prevents such methods transmitting data globally. So it becomes hard for it. So the communication between antennas and satellite is carried out by the radio waves or microwave frequencies. So these are the antennas, senders, and receivers, and the satellites are outside. There are two methods: either the satellite is receiving the signal, sending it back to another receiver, and then receiver that becomes sender sends to another, and this way topsy-turvy way the signal reaches the receiver. On the other hand, the satellites do not send the signal back, rather they communicate among each other and send the signal directly to the receiver on earth. The communication between antennae and satellite is carried out by radio waves or microwave frequencies. Different frequencies bands are used to prevent signal interference and to allow networks spread across the earth to communicate through use of satellites. Many satellites orbits the earth, which I discussed in paper 1 chapter 2, and you may watch that lecture or read that lecture for more information on the use of satellite technology with networks. So that's it about the network, wireless network types. For any question, you need to ask through the post underneath this lecture or via respective discussion groups. Remember, this topic does not require you to know everything in greater detail. It's just for the knowledge and would have short questions. Thank you very much.